Find acceleration of each block, second T1 and T2, third force exerted by the string on the pulleys. The situation is shown in the figure. Shortcut method. We have A equal to net pulling weight divided by total mass to be pulled. Here, mass into acceleration due to gravity minus mass into acceleration due to gravity will give the net pulling weight. So 2g minus 1 into g divided by total mass, 2 plus 1 plus 3, 2 plus 3 plus 1 equals to 2g minus g by 6 equal to g by 6. So we have acceleration g by 6. Now FBD of A, tension is T1 in this direction and weight in this direction, acceleration. So that we can directly write WA minus T1 equal to MA into A, or 2G minus T1 equal to 2 into G by 6 in G by 3. This gives T1 equal to 2G minus G by 3 equal to 5 by 3G Newton. Again, FBT, where G is the acceleration due to gravity. Now FBT of C. In this case, T2 is in upward direction, weight is in downward direction, kg, mass of weight is body C is 1 kg. So T2 minus WC equals to MC into A. Solving this, T2 equals to WC plus MC into A, MC into G plus MC into A, MC to G plus A, putting all value, we get 7 by 6 G Newton. Again, every D of D. T2 is in this direction, T1 is in this direction, R is in outward direction, normal reaction, and weight is in, because there is no vertical motion, only we have to consider horizontal. So T1 minus T2 equals to MB into A. And from this we can calculate there is no need to calculate here because we have already calculated the T1, T2 and the value of A. Now FBT of pulley 1, because in pulley 1 T1 is acting in this direction and T2 is acting, T1 is acting in this direction. There is two tension on the pulley, one in this direction, one in this direction, and because string is same, so tension is same. So resultant will be in this direction, and it is represented by TR. So TR is under root T1 square plus T2 square. T2 here T2 has T1, so under root 2 T1. Again, FBT of pulley 2 in this direction T2 and in this string is same, so both tension is same. So T2 is in this direction, again T2 is in this direction, so the resultant of these two will be TR, and TR is under T2 square plus T2 square equals to under 2. Now this problem can be solved with the general method. In general method we draw an FBT diagram of all bodies, and we get equation from this FBT diagram, and then solve this equation and find the answer. So in general method, for example, for body A, we draw the three body diagram and draw the equation of motion. Then we will get WA minus T1 equal to MB into A. This is equation 1. And similarly for body B, T1 minus T2 equal to MB into A. And for body C, T2 minus WC, that is weight of body C, equal to MC into A. Now adding these three equations, we get WA minus WC, because T1 will be concealed with TT minus T1 and T2 will be concealed with minus T1, only WA minus WC equals to MA plus MB into MC into A, and from this we get A equals to WA minus WC by MA plus MB into MA plus MB plus MC. And now we can calculate, because we know the value of acceleration, so we can calculate T1 from equation 1 and T2 from equation 3. Next question. In the adjacent figure, mass A, B and C are 1 kg, 3 kg and 2 kg respectively. Find the acceleration of each block. Tension in the string. So in this figure, this is a string of same type and this is another string and this is another, so tension in this will be same here and tension and this tensor will be different. Now given m1 equal to 1 kg, mb equal to 3 kg, and m is equal to 2 kg. Now drawing the free body and resolving into it in component form. For example, this is 30 degree and the weight of this block will be acting in this direction. So one component will be in this direction, one component will be in this direction. This is mcg into sine 30 degree. This is mcg into sine cos 30 degree in this direction. Similarly, this block have two component, one in this direction and one in this direction. And this blocks also have one component in this direction, one component in this direction. Now, so using shortcut method, A equals to net weight, pulling weight divided by total mass to be 4. So MA into B G sin 60 plus MB into G sin 60 minus MC into G sin 30 divided by MA plus MB. This is adding this weight in this direction and subtracting this weight, we get net pulling weight, and solving, putting all value, we get acceleration as 4.1 meter per second square. Now let tension between the string A and B is T1 and between B and C is T2. Now every D of A, if we draw the free body diagram video, the T1 will be in this direction. Normally action on A is in this direction. Weight will have two components, one in this direction and another in this direction, as shown in the figure. So we can write directly equation of motion ma into g sin 60 minus t1 equal to ma into a. From this we get the value of t1, ma into g sin 60 minus a Newton. Putting all value, we get finally the value of h 4.56 Newton. Similarly, FBD of C, T2 is in this direction, normal reaction on body C is in this direction. Weight will have two components, one in this direction and another in this direction, as shown in the figure. And now applying the equation of motion, that is T2 minus mc into g sin 30 equals to mass mc into a, here it is. And solving this, again we get T2 equals to mc into g sin 30 plus a. Putting all value, we will have the value 18.2 Newton as answer. Again, FBD of B. On FBD of B, again T2 is in direction, T1 is in direction, and component of weight is in this direction and in this direction. So we take the equation of motion only in this direction because this force is balanced. So MB G sin 60 plus T1 minus 2 into MB into A. MB into A, and solving, we can find the value. Solving this, we can find the desired value.